Hello everyone. So let's go back to what we were doing. Um, so with vector, we learned what is vector addition. We learned what vector subtraction means. So let's analyze things with vector. Vectors obey the law of being associative. So A plus B plus C is equal to the addition of vectors A plus B plus C, and they obey that law. All right, so let's go to the following. Let's go to the following problem. So cross country skier skis 1.00 kilometers north, then 2.00 kilometer east on a horizontal snowfield. How far and in what directions is she from the starting point? How far and what direction is she from starting point? All right, so she starts 1 kilometer north and then 2 kilometers east, so 1 kilometer north and 2 kilometer east, and so the vector is resultant is the displacement over here. Displacement. So she went according to Pythagoras theorem. The displacement, where we will write the letter D, is equal to the Pythagorean theorem of that, which is 1 squared plus 2.00 squared underneath the square root. So that's like about 2.24 kilometers. So we keep 3 significant figures since we are given 3 significant figures. So the uncertainty, the amount of significant figures, we know precisely up to 3 significant figures, not more than that. So this is 2.24 kilometer. So the angle here, so then the angle is tan, is tangent of phi is opposite over adjacent. So this is the angle phi. It's the opposite over adjacent, which is 2.00 kilometers divided by 1.00 kilometer. So that's 2.00. There's no units now since they cancel, so that's a unitless number. So phi is arctan phi is arctan of 2 from the north, from the east. Degree. And so from north, it is 90 minus 63.4, which is 26.6 north of east. So also, this is east of north. Or, so you go in the east and then you go counterclockwise to the north. So, or it's 90 minus 63.4 north of east. So you go from the north to the east. So 90 minus 63.4 degrees, which is 26.6 degrees. All right. So yeah, so that's about it for now. We're gonna see components of vectors. So let's say we have a vector A. Let's draw it. This vector A has an associated x direction and associated y direction. And if we add them up, they contribute to the vector A being stationed as where it is, and the same thing as is its magnitude. So the vector A can be broken down as the vector that goes in the x direction plus the vector that goes in the y direction, and that makes up the vector A. So if we have a vector A, then we can also determine its component as follows. We can determine the direction first of all. So cosine of theta is equal to ax over the length of A, and sine of theta is equal to ay over the magnitude of A, or the length of A. So yeah, so that's vector magnitude, and also tangent of theta, this is ay over A. So we can, given the components, we can determine the magnitude of A. Given the components, also we can determine the direction as well. So that's like that. We will do a lot of problems like that in the next couple of videos. So I will end this video here, and I will see you guys in the next one, where we will solve a problem. And then after that, we will it's a very nice problem. So after that, we will be doing unit vectors and dot products and then cross products. So in approximately like 4 videos, we will be done, or like let's say 6 to 7 videos, we will be done with vectors, the chapters of vectors, and then we'll go to the chapter of like velocity and displacement in one direction. So I'll see you guys later, and then I will be catching you in the next video. Bye.